Example B. Now we have some fractions. These are both positive, so that helps me when I draw my graph. I only need to draw the positive xy axis. And I'm just going to go, you can even do this by fifths if you want, but I'll just do this. I'm going to call this 1 and 1. I don't have to go very far. And here I go. I'm going to go right 3/5, up 4/5. So something like that. That's my terminal point. And there's my vector. That's it. So there's your vector. So again, if I want to actually, and again, I'm just going right 3/5. You know, that looks about 3/5, right? A little over half going right, and almost to 1 going up. It's obviously not perfectly to scale, but it's close enough. Okay, so to find the magnitude, remember what we're going to do. I'm going to go the absolute value of a squared plus b squared. So 3/5 squared plus 4/5 squared. Simplify this, you're going to get 9 over 25 plus 16 over 25. Keep simplifying. 9 plus 16 is 25 over 25. And I get the square root of 1. So that actually came out pretty nice. So the magnitude, or the length of that vector, is just 1. And this has a special name for it, actually. When you get a vector with a length of 1, it has its own special connotation, and this kind of builds on this component vector concept. So that's the next thing we're going to talk about here, and that's going to be unit vectors. So a unit vector is a vector with a magnitude of 1. Obviously, the one that I just did, that's going to be a unit vector. But the two most important ones are those first two I have written. The vectors 1, 0, and 0, 1. Those are the most basic unit vectors you can possibly draw. And this is going to be important when we get into our trig form of vectors. We're going to write our component vectors in the form I and j, in terms of I and j. And there's a reason for that. You'll see when we get to it. But right now we're learning the math. When you see our trig form, you're going to see we're going to use this form a lot. It's going to make complex calculations a lot easier to write this out more like an equation as opposed to, a separate looking form. Like we can do a lot of more complex operations if we have an expression as opposed to, that symbol. So that's why we do it in terms of I and j. We're allowed to do more complex operations with it at that point. So I just represents 1, 0, and j represents 0, 1. And if you kind of think about the way this is currently written, this is just, your horizontal component and your vertical component. And again, I'm about to talk about properties of vectors, so you'll see it used here already. But this is just a, which is your horizontal component of your vector, times the vector 1, 0, plus b times the vector 0, 1. So if you kind of multiplied this through, which is what we're going to do, you'll see in a second, this is just a. So a0 plus, and distribute the b, 0b. Add those up, you're going to combine a and 0, you get a. Combine 0 and b, you get b. So these are exactly the same thing. So you can write them in that form as well. And again, that's going to be very useful as we do more complex work. Okay, so as I was just talking about properties of vectors, and I talked about earlier about adding, subtracting, multiplying, dividing vectors, I said it's the simplest thing you can possibly do. I just did one here. Like if I just gave you this problem, I said do it, solve it. Your first instinct would usually be to I guess I can just distribute the a, I guess, and you'd be right. That's you multiplying by a scalar. And then if you saw this equation right here and say, okay, add them, and you're like, I don't know, maybe I can just add the a and the 0 and the 0 and the b, that'd be hopefully your first instinct, and you'd be correct. That's why I would hope it'd be your first instinct. So it's like common sense kind of rules here. So you'll see that in a lot of these, like if I'm adding vectors, just understand if you're adding and you'll see with the problems that I do here, you just add the horizontal and vertical components. This vector addition, the chart that I have, just kind of shows that the order doesn't even matter. You just add them together however you feel like doing it. If you're adding 0, then, you know, it goes away. It's just very basic, okay? Also, if you're multiplying, notice all I'm doing, if I'm multiplying by a scalar, I just distribute my c. That's it. Or u, whatever the vector is, it doesn't matter what it's called. You just distribute. So again, common sense rules here. So it's easier to kind of show these through these examples, so I'm going to do that now. So for example A, what we're doing is I'm finding a few of these vectors here, and I'm just going to do for the first one, because it gets kind of tedious otherwise, I'm going to do these two operations on example A, and then I will do the negative 4v and the 3u plus 5v for the second example. So here we go. The first one, and I'll even color code it the same way. I'm given my two vectors, and I'm going to just do some basic operations. One's multiplying and the other one's subtracting. So first, let's start off with 2u. So 2 times the vector. I'm multiplying by what's called a scalar. So that's going to look like this. 2 times the vector, negative 2, 3. And as I said, this is as simple as it can possibly be. Hopefully your number one instinct would be to distribute this 2, and you would be correct. So this would be negative 4, 6. Literally, that's it. So that's you multiplying the vector. Basically, it just doubles every number inside the vector. So you're done. Told you it wasn't so bad. Okay. Next up, if I do u minus v, again, same basic concept. You use your instincts and you'll be okay. So if I'm subtracting these, I'm just going to go negative 2, 3 minus 5, negative 4. So if I'm going to subtract these, I'm just going to write this now. I'm going to take my horizontal components. I'm going to subtract those. So negative 2 minus 5. I subtracted my two horizontal components. And I'm going to go 3 minus negative 4. So I'm subtracting my vertical components. So if you want to combine these by subtraction, you're going to get negative 7. And then 3 plus 4 is going to be positive 7. So I said common sense rules here. Okay, so that's you working with component vectors. Now we're dealing with them in terms of I and j. It's, again, the same basic premise here, so don't try to overthink this. But I'm going to start with negative 4v. So I'm going to go negative 4 times v for my first example. So here I go. So I'm going to go negative 4, and this is my vector in terms of I and j. So it's going to be more like an expression. It's going to be 3i minus 2j. This is in terms of I and j, that those are your two unit vectors. Okay, so now I distribute. It looks a little bit cleaner now because it is parentheses, so it might be a little more obvious. But this is going to be negative 12i, and then negative 4 and negative 2 is actually plus 8j. And you are all set. By the way, just so you can kind of see the connection here, this is nothing more than the component vector negative 12, 8. So if you had to go graph that, that's all you're doing. But I want the answer written in terms of I and j. That's what we're working with. But just to make sure you understand what that actually is. Okay? And then v. Or sorry, not v. 3u plus 5v. So I'll write that out here. So 3u plus 5v. All right. So in order to do this, I have to first find out what is 3u. And then I'm going to find out what 5v is. So let's start with the 3u. With 3u, I have 3 times, and u is just I plus j, so that one's kind of easy to do. So this would be 3i plus 3j. And next I'm going to go ahead and do my 5v. So 5v equals 5 times 3i minus 2j. So that's going to equal 15i minus 10j. So now that I have those two, I can subtract them. So the 3i is going to be 3i plus 3j. And I'm subtracting that from the quantity. Make sure you put parentheses in this. 15I minus 10J. It's best sometimes you just put parentheses in both, but it doesn't really matter in the first one. So now when you subtract, understand you're distributing that negative. So I'm going to have 3 minus 15 for my i's. So that's going to be negative 12i. And I'm going to have 3 minus 10 for my j's. So it's going to be minus 7j. And again, as a reminder, I want you to write it how I have it, unless I tell you specifically. But otherwise, just know that this vector in component form is negative 12, negative 7. If you had to go graph it, you can kind of look at it that way. So that is the basics of vectors, just some basic operations. Here's your homework for this. And again, you know, a lot of this is just kind of repetitive, getting used to the process. So I just gave you every other odd here, just so you can see a little bit of each scenario that you might possibly see. So this is Blue Book 7.5. Again, 1 through 25, every other odd means 1. Skip 3, do 5. Skip 7, do 9, and so on. Okay, so you will see, again, I have a short video for Tuesday, so this one is, you know, a little bit longer, but, you know, you can also just do both videos on Monday and do the work on Tuesday. It's really up to you. Just make sure both lessons are done and understood and the homework's complete by the time I see you on Wednesday or Thursday. If there's any questions, I will take care of them then. So with that, go ahead and